Good day, everyone. So today I'll be discussing energy resources, and in this chapter, we will be able to answer these following key questions. What is net energy and why is it important? What are the advantages and disadvantages of using fossil fuels? What are the advantages and disadvantages of using nuclear power? Why is energy efficiency an important energy resource? What are the advantages and disadvantages of using renewable energy resources? And how can we make the transition to a more sustainable energy future? Energy resources vary greatly in their net energy yield. So what is net energy yields? It is the total amount of high-quality energy available from a given quantity of an energy resource minus the high-quality energy needed to make the energy available. For example, if the energy produced is 100% and you consumed 40% of it, then the net energy yield is 60%. It is also classified as high, medium, low, and negative or net energy loss. It is important as it is used to evaluate the long-term economic usefulness of different energy resources. Without it, we could be using or consuming sources that are costing us more energy than what is provided. Net energy yields are based on the first and second laws of thermodynamics. Fossil fuel, it includes coal, oil, and natural gas and are currently abundant and world's primary source of energy. It also supplies most of our commercial energy. In 2012, the three world's largest users of commercial energy are China with 22% of the global total, United States with 18%, and Russia for 6%. These figures shows the energy used by source throughout the world and energy consumption of United States. So as you can see in the left side, most of the energy comes from non-renewable energy with 91%, 87% from fossil fuels such as oil with 33%, natural gas with 24%, and coal with 30%. 4% for nuclear power. And the remaining 9% of the commercial energy comes from renewable energy, such as hydropower with 7%, geothermal, solar, wind, and biomass with 2%. On the other side, these are the energy consumption of United States, wherein you can see that they consume energy more than what is provided, especially in non-renewable energy, which is 95%, fossil fuel such as oil with 37%, and natural gas with 30%, and also in nuclear power with 8%. So this is the first type of fossil fuel. Crude oil or petroleum. It is a black gooey liquid containing a mixture of combustible hydrocarbons along small amounts of sulfur, oxygen, and nitrogen impurities. It is found beneath layers of impermeable rock within the Earth's crust on land or under the seafloor. So this is a crude oil or petroleum. When oil is found, oil companies will drill holes and remove rock cores from potential oil deposit areas to see whether there is enough oil to be extracted profitably. So this is the rock cores, this one. If they found an oil, then they will drill for one or more wells. And after years of pumping, the pressure in a well drops and its rate of conventional crude oil production starts to decline. This point of time is called peak production. Global peak production occurs when the rate of global production of crude oil begins to decline faster. If this happens, we can expect that net energy yields from crude oil will decline and oil price rises. Crude oil from a well cannot be used as it is. We need to process it, which is called refining, wherein it is transported to refinery by pipeline, truck, rail, or ship or oil tanker, where it is heated to separate it into various fuels and other components with different boiling point. It produces large quantities of petroleum coke or petcoke. About 2% of the products of refining called petrochemicals are used as raw materials to make industrial organic chemicals, cleaning fluids, pesticides, plastics, synthetic fibers, paints, medicines, cosmetics, and many other products. Since it is consumed for greater amount, as it is the lifeblood of our economies, so we can ask ourselves if the world running out of crude oil. Well, no one knows, but there is so-called proven oil reserves, which is the deposits from which the oil can be extracted profitably at current prices using current technology. The world is not about to run out of crude oil in the near future, since we can produce more conventional light crude oil from far offshore in deep ocean seabed deposits and from remote areas with severe climates, and we can also rely more on unconventional heavy oil and other sources. However, it would lead to lower net energy yields, higher environmental impact, higher production costs, and higher oil prices. The 12 countries that make up the Organization of Petroleum Exporting Countries, or OPEC, have about 72% of the world's proven crude oil reserves and are likely to control most of the world's conventional oil supplies for many years to come. So, the OPEC's members are Algeria, Angola, Ecuador, Iran, Iraq, Kuwait, Libya, Nigeria, Qatar, Saudi Arabia, United Arab Emirates, and Venezuela. Its advantages and disadvantages. First, advantages: ample supply for several decades, net energy yield is medium but decreasing, low land disruption, efficient distribution system, and in disadvantages, water pollution from oil spills and leaks, environmental costs not included in market price, releases carbon dioxide and other air pollutants when burned, and lastly, vulnerable to international supply interruptions. Heavy oil. It is also a type of fossil fuel. A potential supply of heavy oil is shale oil, which is the oil that is integrated within bodies of shale rock. So, in this picture, you can see shale rock on the left side and shale oil in the right side. Producing it involves mining, crushing, and heating oil shale rock to extract a mixture of hydrocarbons called kerogen that can be distilled to produce shale oil. About 72% of the world's estimated oil shale rock reserves are buried deep in rock formations located primarily under government-owned land in the U.S. states of Colorado, Wyoming, and Utah. However, the net energy yield for this energy resource is low and the process has a large and harmful environmental impact. A growing source of heavy oil is tar sands or oil sands, which are a mixture of clay, sand, water, and bitumen. 3/4 of the world's tar sands resource is located at northeastern Alberta in Canada in sandy soil under a vast area of remote boreal forest. According to a 2014 Canadian government report, the largest producer of Canada's greenhouse gases is its energy sector, with over 70% of the emissions coming from its tar sand industry. Since 2005, there has been a controversy over building the Keystone XL pipeline, which would allow Canada to send its heavy crude oil through the United States to Gulf Coast refineries. Its advantages and disadvantages. So first, in advantages, large potential supplies, easily transported within and between countries, efficient distribution system in place, while in disadvantages, low net energy yield, releases carbon dioxide and other pollutants when produced and burned, and lastly, severe land disruption and high water use. Next is natural gas. It is a mixture of gases of which 50% to 90% is methane. It also contains smaller amounts of heavier gaseous hydrocarbons such as propane and butane, and small amounts of highly toxic hydrogen sulfide. This has a medium net energy yield and is mostly used for cooking, heating, and industrial purposes. It can also be used as a fuel for cars and trucks and for natural gas turbines used to produce electricity in power plants. Its versatility helps to explain why it provides about 28% of the energy and 27% of the electricity consumed in the United States in 2013. It is often found in deposits lying above deposits of conventional oil. It also exists in tightly held deposits between layers of shale rock and can be extracted through horizontal drilling and fracking. When a natural gas deposit is tapped, propane and butane gases can be liquefied under high pressure and removed as liquefied petroleum gas. So most of us is using this, especially while cooking. LPG is stored in pressurized tanks for use mostly in rural areas not served by natural gas pipeline. The rest of the gas purified and pumped into pressurized pipelines for distribution across land areas. Natural gas can also be transported across oceans by converting it to liquefied natural gas or LNG. The three countries considered as the world's largest proven natural gas reserves are Iran with 18% of the global total, Russia with 17.6%, and Qatar with 13.4%. The US had only 4.5% and China with 1.7%. In 2012, the three world's largest producers of natural gas are United States, Russia, and Iran. United States with 20% of global production and 22% of consumption, Russia 18% of global production and 11% of consumption, Iran with 5% of production and 5% of consumption. Is its advantages and disadvantages. First, in advantages, ample supplies, versatile fuel, medium net energy yield, emits less carbon dioxide and other air pollutants than other fossil fuels when burned, while in disadvantages, low net energy yield for LNG, production and delivery may emit more on carbon dioxide and methane per unit of energy produced than coal, fracking uses and pollutes large volumes of water, potential groundwater pollution from fracking. Next is coal. So we all know what is coal, right? So it is a solid fossil fuel formed from the remains of land plants that were buried and exposed to intense heat and pressure for 300 to 400 million years. In 20%, coal-burning power plants generated about 40% of the world's electricity, 39% of the electricity used in the United States, and 65% of that used in China. So the three largest producers of coal are China, United States, and Australia. So China produced 48%, while they consumed 50%. United States 13% of production, while 12% of consumption. Australia, one of the largest producer of coal, 6%. And India is one of the largest consumer. So they consumed with 8%. Largest proven coal reserves at United States with 28%, Russia with 18%, and China with 13%. According to a 2010 study by the Clean Air Task Force, fine particle pollution in the United States, mostly from the older coal burning power plants without the latest air pollution control technology, kills at least 13,000 people a year. According to a 2010 study by University of Washington scientists and World Health Organization in China, outdoor air pollution from the burning of coal contributes to 1.2 million premature deaths per year, or 137 deaths per hour. Because of increasing competition from cleaner burning natural gas, few new coal burning power plants are being built in the United States and some older ones are being closed. So the following are the advantages and disadvantages. Its advantages: ample supplies in many countries, medium to high net energy yield, low cost when environmental costs are not included. While in disadvantages, severe land disturbance and water pollution, fine particle and toxic mercury emissions threaten human health, emits large amounts of carbon dioxide and other air pollutants when produced and burned. So next is nuclear power. Nuclear power plants heat water to produce steam. The steam is used to spin large turbines that generate electricity. It is complex and costly because of the use of controlled nuclear fission reaction to provide heat. Nuclear reactors are the heart of a nuclear power plant. It is because nuclear fission occurs. Nuclear fission is the process where atoms split and release energy. The most common reactor is cold light water reactors. It produces 85% of the world's nuclear generated electricity. So there are two types of light water reactors. These are pressurized water reactor and boiling water reactor. So in pressurized water reactor, these reactors pump water into the reactor core under high pressure to prevent the water from boiling. While in boiling water reactor, heat water and produce steam directly inside the reactor vessel. So in nuclear power, it starts in mining a uranium from the Earth's crust as it is used for nuclear fuel. The uranium into small ceramic pellets and stacked together in the fuel rods, then grouped together in fuel assemblies to be placed in the core of a reactor. To regulate the amount of power produced, plant operators use control rods, moving them into and out of the reactor core to absorb more or fewer neutrons, thereby slowing or speeding the fission reaction. A coolant, usually water, circulates through the reactor's core to remove heat and keep the fuel rods and other reactor components from melting and releasing massive amounts of radioactivity into the environment. An LWR or light water reactor includes an emergency core cooling system as a backup to help prevent such meltdowns. In 2013, nuclear power produced about 4% of the world's energy and 8% of the energy used in the United States, and the leading producers were United States, France, and Russia. So the advantages and disadvantages of nuclear power. First, in advantages, low environmental impact without accident, emits 1/6 as much as carbon dioxide as coal, low risk of accidents in modern plants, and while in disadvantages, low energy yield, high overall cost, produces long-lived harmful radioactive wastes, promotes spread of nuclear weapons. Next is why is energy efficiency an important energy resource? Energy efficiency is a measure of how much useful work we can get from each unit of energy we use. Improving energy efficiency means using less energy to provide the same amount. So, in this figure, there are 100% of energy, high quality energy, but there are only 16% performs useful tasks. So 41% is unavoidable energy, while 43% of energy is wasted, mostly because of the inefficiency of industrial motors, most motor vehicles, power plants, and numerous other energy-consuming devices. So, improves energy efficiency. First is prolongs fossil fuel supplies, reduces oil imports and improves energy security, low cost, very high net energy yield, creates local jobs, reduces pollution and environmental degradation, and buys time to phase in renewable energy. So the advantages and disadvantages of renewable energy resources. So type of energy, as you can see in the table, there is a column for type of energy. Second column is advantages and last column is for disadvantages. So first is wind energy. Advantages of wind energy are no air or water pollution, free source of energy, wind farms are relatively inexpensive, the land of the wind farms can be used for other purposes, while its disadvantages are requires constant and significant amount of air, requires significant amount of space, have visual impact on landscapes. Next is solar energy. Its advantages are infinite source of energy supply, no air and water pollution, while disadvantages are manufacture and implementation of panels are costly, storage and backup is mandatory, workability depends on the availability of sunlight. Next is hydropower. Its advantages are sources are abundant, clear and safe, no standby losses, relatively inexpensive. On the other hand, disadvantages are costly to build, can cause us flood, uncertainty of availability of water. Bioenergy. Its advantages are cheap to construct, burns waste products, while disadvantages are when burns it gives off atmospheric pollution, including GHGs. Biomass is only renewable if the crops are replanted. Geothermal energy potential its advantage is potentially infinitive energy supply, while disadvantages setup and development cost can be expensive. We can improve energy efficiency in industries and utilities through cogeneration, which involves using a combined heat and power or CHP system, use more energy efficient electric motors, recycling materials, use more energy efficient compact fluorescent and LED lighting, redesign the software and cooling systems in electronic data processing systems. So that's all, and the continuation of this topic will be discussed by Gennelyn Real.
Okay, so in continuation, I am Gennelyn Ariel and we will be discussing about the using of renewable energy, heating building and waters with solar energy. Cool buildings naturally concentrate sunlight to produce high temperature heat and electricity. Use solar cells to produce electricity from falling and flowing water. Use wind to produce electricity, convert plants and plant waste to liquid biofuels. Produce energy by burning solid biomass, get energy by tapping the Earth's internal heat, hydrogen, and choosing energy paths. So these are the things that we are going to tackle. Okay, so why are we wasting so much energy and money? So according to the conservative estimates by the International Energy Agency and the Global Subsidies Initiative in 2011, there are three reasons why we waste so much energy and money. First, government around the world spent more than $620 billion on subsidies for the highly profitable fossil fuel industry compared to $88 billion on subsidies for renewable energy. Second, there are few long-lasting government tax breaks, low-interest long-term loans, and other economic incentives for investing in energy efficiency. Third, some governments have not put a high priority on educating the public about environmental and money-saving advantages of improving energy efficiency. So those are the three main reason why we are wasting so much energy and money. Okay, now so we have here some tips to save energy and money where you live. In an attic, use house fan and hang reflective foil near roof to reflect heat. In bathroom, repair water leaks promptly. In kitchen, clear refrigerator coals regularly. So if you have any refrigerators. In outside our house, plant trees to block summer sun and let cool air in. In other rooms, we can use fans instead of air conditioning. Okay, so we can use renewable energy for many purposes. So by using a mix of renewable energy resources, we can satisfy our energy needs while reducing pollution, greenhouse gas emissions, and biodiversity losses. Okay, so there are three scientific principles of sustainability. First, rely on solar energy. Second, geothermal energy. Third, heat from the Earth's interior. Okay, so China is by far the world's largest user of coal and leads the world in climate-changing carbon dioxide emissions. Also has the world's largest capacity for electricity from wind power and solar cells, and plans to become the largest user and seller of wind turbines. So this country's goal is to greatly expand its production of electricity from renewable wind to help reduce its use of coal and outdoor air pollution. So Ibrahim Togola promotes the use of renewable energy resources like solar, wind, and biofuel to produce electricity in rural areas. His goal is to reduce deforestation caused by reliance on wood and charcoal and contribute to wealth creation. Okay, so there are four major reasons renewable energy provides only 8% of the world's energy. First, government tax breaks, subsidies, and funding for research and development of this energy have been much lower than those of fossil fuels and nuclear power. Second, this energy in United Nations have to be renewed by Congress every few years, which results to political pressure from the fossil fuel industry trying to head off a competition from these rapidly developing technologies. Third, prices we pay for non-renewable fossil fuels and nuclear power do not include most of the harmful environmental and human health costs of producing and using them. Fourth, it takes 50 to 60 years to make the transition from one dominant fuel to another, such as from wood to coal and from coal to oil and natural gas. Alright, so those are the four major reasons. Okay, so heat building and water with solar energy. So a building that has enough access to sunlight can get all or most of its heat through passive solar heating system. So such a system absorbs and stores heat from the sun directly within a well-insulated structure. So an active solar heating system captures energy from the sun by pumping a heat-absorbing fluid through special collectors. Rooftop active solar collectors are used to heat water in many homes and apartment buildings. So according to the UN Development Program, solar waters heated could be used to provide half of the world's hot water. So there are passive and active solar systems which can be used to heat new homes in area with adequate sunlight. Okay. So, cool buildings naturally. So, direct solar energy works against us when we want to keep a building cool. But we can use indirect solar energy to keep cool buildings. Say, for example, we can open our window to let the air come into our house. Okay, so there are three other ways to keep our house cool. First, block the high summer sun with shade trees. Second, use light-colored roof for sun's reflection. Third, use geothermal heat pumps to pump cool air from underground into a building. Okay. These are just some common ways how to keep our house cool. Now, so concentrate sunlight to produce high temperature heat and electricity. So solar thermal systems, also known as concentrated solar power, uses different methods to collect and concentrate solar energy in order to boil water and produce steam for generating electricity. Such system uses troughs of curved collectors that concentrate solar energy and use it to heat synthetic oil in a pipe that runs through the center of each trough. Okay. So this concentrated heat is used to boil water and produce steam that powers a turbine that drives a generator to produce electricity. Another system uses an array of computer-controlled mirrors to track the sun and focus its energy on a central power tower to provide enough heat to boil water that is used to produce electricity. So the heat produced by either of these systems can also be used to melt certain kind of salt stored in a large insulated container. The heat stored in this molten salt system can then be released as needed to produce electricity at night or on cloudy day. So one problem with solar thermal systems is that their net energy yield is low, which means that they need large government subsidies or tax breaks in order to compete in the marketplace with alternatives that have higher net energy yields. Some sunny rural areas, people use inexpensive solar cookers to focus and concentrate sunlight for boiling and sterilizing water and for cooking food. So these can replace wood and charcoal fires, which help to reduce indoor air pollution. This also helps to reduce deforestation by reducing the need for firewood and charcoal. Okay, so now we have here solar thermal system advantages and disadvantages. So for advantages, it is high potential for growth, source of new job, lower costs with natural gas turbine backup. And for our disadvantages, it is low net energy yield and high costs, requires high water use, can disrupt desert ecosystems. Nevertheless, we can still use solar thermal systems. Okay, so use solar cells to produce electricity. We can convert solar energy directly into electrical energy using photovoltaic cells, or commonly called solar cells. These are thin wafers of purified silicon with trace amounts of metals that allow them to produce electricity. These have no moving parts and they operate safely and quietly with no emissions of pollutants or greenhouse gases. So a typical solar cell has a thickness ranging from less than of a human hair to that of a paper. Okay. So we can mount arrays of solar cells on rooftops and incorporate them into almost any type of roofing materials. Almost 1 of every 5 in the world do not have access to electricity that most of us take for granted. So as these small off-grid system reach more rural villages, they will help hundreds of millions of people to lift themselves out of poverty. Okay, so through these solar cells. Okay, so solar cells emit no greenhouse gases. These typically convert only 20% of the incoming solar energy into electricity. So conventional solar cells also contain toxic materials that must be recovered when the cells wear out after 20 to 25 years of use, or when they are replaced with new system. So there is one problem with solar cells, and it is they have a low to medium net energy yield, depending on the design and the production process. Now let's have the solar cells advantages and disadvantages. As for our advantages, it is a medium net energy yield, competitive costs for newer cells, easy to install, move around, and expand as needed. For our disadvantages, it needs access to sun. Solar cell power can disrupt desert ecosystems, and some designs have low net energy yield. So Jim Loynes, former chief engineer for General Electric, contends that solar cells will be the world's #1 source of electricity by the end of this century. If that happens, it will represent a huge global application of the solar energy principles of sustainability that would sharply reduce air pollution and help to slow climate change. Okay, so that's according to Jim Loynes. Now let's continue. So produce electricity from falling and flowing water. So hydropower is any technology that uses the kinetic energy of flowing or falling water to produce electricity. It is an indirect form of solar energy because it depends on the evaporation of water, which is deposited as rain or snow at higher elevations. Most common approach to harnessing hydropower is to build a high dam across a large river to create a reservoir. Okay, so as you can see in the background, some of the water stored in the reservoir is allowed to flow through large pipes at a controlled rates to spin turbines that produce electricity. This is the leading renewable energy resource. So there are 3 world's top producers of hydropower, and these are China, Brazil, and United States. Large-scale hydropower advantages and disadvantages. For our advantages, it is low costs electricity, low emission of CO2 or carbon dioxide and other air pollutants, high net energy yield. For our disadvantages, it disrupts downstream aquatic ecosystems and large land disturbance and displacement of people. So the use of micro hydropower generators may become an increasingly important way to produce electricity. These are floating turbines and can be replaced in any stream or river without altering its course to provide electricity at a very low cost with a very low environmental impact. We can also produce electricity from flowing water by tapping into the energy from ocean tides and waves. Okay, so in 2014, China was building a pilot plant to evaluate the feasibility of producing electricity by using the difference in temperature between warm surface water and cold deep water. The United States experimented with this approach, called ocean thermal energy conversion, but abandoned it because of its high costs. Now, using wind to produce electricity is an important step towards sustainability. Since 1990, wind power has been the world's second fastest growing source of electricity after solar cells. Fewer than 10 years, China built the world's largest wind power capacity and plans to triple it in the year 2020. Even though offshore wind farms are more costly to install, analysts expect to see increasing use of them because they can harness stronger winds and thus reduce the cost of producing electricity. So the leaders in building offshore wind farms were Great Britain, Denmark, Belgium, Germany, China, Netherlands, Sweden, and Japan. Okay. So wind power advantages and disadvantages. So for advantages, high net energy yield, widely available, easy to build and expand. For our disadvantages, it can kill birds, low level noise, bothers some people, and visual pollution for some people. So wind is abundant, widely distributed, and inexhaustible. Wind power is mostly carbon-free and pollution-free. Although wind farms can cover large area of lands, the turbines occupy only a small total area of land. A typical wind turbine can generate enough electricity to meet the needs of more than 1,000 homes. In addition, wind power has a medium to high net energy yield. If you are going to apply the full costs pricing principle of sustainability, the three which I was able to mention earlier, wind energy would be the least costly way to produce electricity. Okay, now let's have produce energy by burning solid biomass. So biomass consists of plant materials that can be burned as a solid fuel or converted into gaseous or liquid biofuels. For example, woods, wood wastes, charcoal made from wood, and agricultural wastes such as sugar cane stalks, rice husks, and corn cobs. Solid biomass is burned mostly for heating and cooking, but also for industrial processes and for generating electricity. Wood is a renewable fuel only if it is not harvested faster than it is replenished. So the problem is countries face a fuel wood crisis and are often forced to meet fuel needs by harvesting wood faster than new vegetation can grow. So another problem, clearing the forests and grasslands to provide the fuel reduces biodiversity and the amount of vegetation that would otherwise capture climate-changing carbon dioxide. Burning of wood and other forms of biomass produces CO2 and other pollutants. One way to deal with this is to plant fast-growing trees, shrubs, and perennial grasses in biomass plantations. But repeated cycle of growing and harvesting these plantations can deplete the soil of key nutrients. Okay, so we have the advantages and disadvantages for our solid biomass. So for our advantages, it is widely available in some areas. It is moderate costs, and plantation can help restore these degraded lands. For our disadvantages, it contributes to deforestation. Clear cutting can cause erosions, water pollution, and loss of wildlife habitat, and can open ecosystem to invasive species. Okay. So, convert plants and plant wastes to liquid biofuel. So, liquid biofuels such as ethanol and biodiesel are being used increasingly to fuel motor vehicles. The biggest producers of biofuel are United States, which is ethanol from corn, Brazil, ethanol from sugarcane residues, European Union biodiesel from vegetable oils, China, ethanol from non-grain plant. Okay, so biodiesel have three major advantages over gasoline and diesel fuel produced by oils. These are: first, biofuel crops can be grown throughout much of the world, and these help countries to reduce dependence on imported oil. Second, there is no net increase in CO2 emissions if and only if used based on harvest times. Third, easy to store and transport through existing fuel networks and can be used in motor vehicles at little additional costs. So globally, ethanol production rose rapidly, especially in UN and Brazil. Alright, so as mentioned earlier. So an alternative to corn-based ethanol is cellulosic ethanol produced from the edible cellulose that makes up most of the biomass of plants. So another approach involves converting a mixture of algae and water to crude oil in less than an hour by subjecting the mixture to high temperature and pressure in a cooker. Okay. So, a UN report on bioenergy, scientists warned that large-scale biofuel crop farming could diminish biodiversity by expanding the cleaning of natural forests and grasslands, increase soil degradation, and erosion. So, so there are advantages and disadvantages for our liquid biofuels. For advantages, it reduces CO2 emissions for some crops, a medium net energy yield for biodiesel from oil palms, and medium net energy yield for ethanol from sugar cane. For our disadvantages, fuel crops can be invasive for species, higher CO2 emission from corn ethanol, and fuel crops can compete with food crops for land and raise food prices. So the challenge here is to grow crops for food and biofuels by using more sustainable agriculture with less irrigation, land degradation, air and water pollution, greenhouse gas emissions, and degradation of biodiversity. So let's move on to get energy by tapping the Earth's internal heat. So, geothermal energy is a heat stored in soil, underground rocks, and fluids in the Earth's mantle. We can tap this stored energy to heat and cool buildings and to produce electricity. One way to capture geothermal energy is by using a first geothermal heat pump system. So, it can heat and cool a house by exploiting the temperature difference between the Earth's surface and underground at a depth of 3 to 6 meters, as you can see in the picture in your right. So according to the EPA, well-designed geothermal heat pump system is the most energy efficient, reliable, environmentally clean, and cost-effective way to heat and cool space. So we can also tap into deeper, concentrated hydrothermal reservoirs of geothermal energy. This is done by drilling wells into the reservoirs to extract their dry stream, which is low water content, for wet stream, high water content, or hot water, which are used to heat homes and buildings. So the United States is the world's largest producer of geothermal electricity from hydrothermal reservoirs. It meets the electricity needs of about 6 million Americans and supplies 6% of Californians' electricity. Another source of geothermal energy is, second one, hot dry rock found 5 or more kilometers underground almost everywhere. Water can be injected through wells drilled into this rock. Some of these water becomes steam that is brought to the surface and used to spin the turbines to generate electricity. So limitation factor of producing geothermal energy in UN is cost, which could be brought down by more research and improved technology. However, there is a concern that tapping this deep source geothermal energy could increase the frequency of earthquakes in the drilled area. So that's according to geothermal engineers. Okay, now, so will hydrogen save us? So some scientists say that the fuel of the future is hydrogen gas. Widespread use of hydrogen as a fuel for running motor vehicles, heating buildings, and producing electricity would eliminate most of the outdoor air pollution. It would also greatly reduce the threat of projected climate change. This also provides more energy per gram than does any other fuel. So there are 3 challenges in turning the vision of hydrogen as a major fuel into reality. These are: first, there is hardly any hydrogen gas in the Earth's atmosphere. Second, fuel cells are the best way to use H2O to produce electricity, but current versions of fuel cells are expensive. Last, we could use electricity from coal burning and nuclear power plants to decompose water in H2O and O2. But this approach does not avoid the harmful environmental effects. Alright, so those are the 3 challenges in turning the vision of hydrogen. So, for now, hydrogen's negative net energy yield is a serious limitation and means that this fuel will have to be subsidized in order for it to compete in the open marketplace with fuels that have medium to high net energy yields. Alright, so let's know the advantages and disadvantages for hydrogen. So for advantages, it can produce from plentiful water at some sites, good substitute for oil, high efficiency in fuel cells. Disadvantages: negative net energy yield, high costs create need for subsidies, and last, needs H2O storage and distribution system. Alright, so choosing energy paths. How can we make the transition to a more sustainable energy future? We can make the transition to a more sustainable energy future by greatly improving energy efficiency, using a mix of renewable energy resources, and including the environmental and health costs of energy resources in their market prices. So there are three general conclusions in choosing energy paths. First, during this century, there will likely to be gradual shifts from dependence on non-renewable fossil fuels to a mix of renewable energy from the sun, wind, flowing water, and the Earth's interior, which is geothermal energy. Second, a combination of improved energy efficiency and careful regulated use of natural gas will be the best way to make the transition to using mostly renewable energy resources during this century. Third, because fuels are still abundant and artificially cheap, we still continue to use them in large quantities. This presents two major challenges. First, to find ways to reduce the harmful environmental and health impacts of widespread use of fossil fuels, and to find ways to include more of the harmful environmental and health costs using fossil fuels in their market prices. So, those are the three general conclusions in choosing energy paths. Okay, so when we have the creativity, the wealth, and most of the technology needed to make the transition to a cleaner and more sustainable energy future within our lifetime, thereby greatly increasing our beneficial environmental impact. So making this transition depends primarily on education, economics, and politics. So what can you do? We have here 4 simple things which we can do to save energy and money. So first, walk or bike or use mass transit to get to work or school. This is possible only if your school or your work is near from your home. Second, have an energy audit done in the place where you live. Third, for cooling, open windows and use fans. Fourth, turn off lights, TVs, computers, and other electricities when it's not in use. Of course. Alright. Now, we have here some big ideas to ponder. First, in evaluating energy resources, we should consider their net energy yields and the environmental and health impacts of using them, as well as their potential supplies. Second, by phasing in a mix of renewable energy resources, especially solar, wind, flowing water, and sustainable biofuels and geothermal energy, we could drastically reduce pollution, greenhouse gas emissions, and biodiversity losses. Third, making the transition to a more sustainable energy future will require sharply increasing energy efficiency using a mix of renewable energy resources and including the harmful environmental and health costs of energy resources in their market prices. Alright, so thank you so much for listening. Those are all our lesson for energy resources. Okay, so this is Gennelyn Real again, and thank you so much for listening.